Hello geometry students, today's learning target is to review Unit 7, which is radicals. So if you look at the first problem, the idea is we want to find a perfect square that goes into 48, and that would be 16, because 16 times 3 is the square root of 48, and then that simplifies to 4 square root of 3. In problem number 2, again, we want to find a perfect square that goes into 54. And 54 is 9 times 6, and the square root of 9 is 3, so we get 3 square root of 6. And as a quick reminder, the perfect squares are 1, 4, 9, 16, 25, 36, 49, 64, 81, and 100, and so on. If we look at problem number 3, we want to do what we did in problem number 1 and number 2 multiple times. So we want to simplify the square root of 45. We also want to simplify the square root of 12. So for the first term here that I'm underlining in red, this would be 2 times the square root of 9 times the square root of 5. The second term, which I'm underlining in blue, would be minus 2 times the square root of 4 times the square root of 3. And then the third term, which I'm going to underline in green, is going to be 2 times the square root of 9 times the square root of 5. Simplifying the red, it's 2 times 3 square root of 5. Simplifying the blue, it's minus 2 times 2 square root of 3. And simplifying the green, it's 2 times 3 square root of 5. So we have 6 square root of 5 minus 4 square root of 3 plus 6 square root of 5. And then we could add the common radicals, meaning we could add the 6 root 5 and the 6 root 5. And in order to do that, we add the numbers in front. So we'll have 12 square root of 5 minus 4 square root of 3, because we cannot combine the root 5 and the root 3. Taking a look at problem number 4, one thing I noticed, I could add these two terms that I kind of put a bracket around. So this is a 1 square root of 3, so you get 2 square root of 3 plus 2 root 12, and the reason is the 3 and the minus 1 becomes that 2. Now we could break down 2 root 12, so it's going to be 2 root 3 plus 2, and 12 is square root of 4 times square root of 3. So that simplifies to 2 root 3 plus 2 times 2 root 3. That becomes 2 root 3 plus 4 root 3. And combining the 2 and the 4, we get 6 square roots of 3. Looking at problem number 5, we want to simplify this completely. So we could multiply the two numbers in front, so we get 8. We could multiply the two numbers underneath the square root, so we get square root of 20. At that point, 20 is the square root of 4 times the square root of 5. Square root of 4 becomes 2. So the final answer here is going to be 8 times 2, which is 16 root 5. Let's practice that again in number 6. We're going to multiply the 5 and the 2. So that's going to be 10. We're going to multiply the numbers under the radical. So that will become the square root of 24. The square root of 24 breaks down into the square root of 4 times square root of 6. The square root of 4 is 2. So the final answer will be 20 square root of 6. The last two problems use the technique of rationalizing, which means we're going to multiply by the square root of 3 over the square root of 3. So when I look at this problem, I see the square root of 3 in the denominator. So I'm going to rationalize by multiplying by root 3 over root 3. Then I'm going to multiply across, so you get 4 root 3 over the square root of 9. And the square root of 9 reduces to 3. So the final answer is 4 root 3 divided by 3. Rationalizing number 8, I'm going to multiply by square root of 2 over square root of 2. I'll multiply across, so you get 10 root 2 over the square root of 4. That becomes 10 root 2 over 2. And now you have an extra step because 10 and 2 you could simplify. So that'll become 5 root 2.